In this video I'm going to show you how I made a staccato controller for my vacuum tube Tesla coil using one of these. This is a microcontroller called Arduino Nano, which you might be familiar with already. Even if it is quite old and slow compared to many other microcontrollers on the market nowadays, it's still fast enough to follow the 50 Hz sine wave of the mains. Let's take a look at the schematics. You will find a link to all documentation from the description. First, we have a 12-volt transformer fed from the mains. Then a rectifier bridge, 1000 microfarad capacitor, voltage regulator for 12 volts. This regulated 12 volts DC goes into the Arduino Nano. Here we have a half-wave rectifier with one diode, a voltage divider of two 1 kΩ resistors, a 4.7 volt Zener diode, 100 nanofarad capacitor for filtering. This regulated half-wave goes into the analog pin A1 of Arduino Nano. Here we have a simple push button and a pull-down resistor connected to digital pin number 2, 3 potentiometers connected to analog inputs number 2, 3 and 4, LED and a resistor connected to digital pin 13, and finally a triac connected to digital pin number 12. This is my test setup on a breadboard. The microcontroller, a transformer, bridge rectifier, capacitor and voltage regulator, half-wave rectifier, one diode, the voltage divider, Zener diode, and this wire goes to the analog input of the Arduino. A push button, 3 potentiometers, output resistor, and these two wires go to the triac of the Tesla coil. This is the Tesla coil I'm using for testing. It's a double 811 coil I made few years ago, actually operating on two 572 tubes at the moment. So let's switch on the power and see how it works. I am behind the isolating transformer, so I cannot get the shock when working on one hand. Here on the oscilloscope, the yellow line is the half-wave rectified 5-volt signal that goes into the Arduino. The blue line is the trigger pulses that the microcontroller is producing. At the moment the trigger pulse is given on every single half-wave, so 50 times a second. This can be adjusted with one of the potentiometers from every single half-wave to only one in a second. With the other potentiometer you can adjust how many pulses you want in a row. It can get values from 1 to 25. With the third potentiometer you can adjust the timing of the pulse. This will affect the power of the sparks produced by the coil. Now let's fire up the Tesla coil and see how this is working. I blew up the fuse on my smaller auto transformer and didn't have a replacement, so I took my bigger auto transformer instead. Here you can see how the timing of the pulse is working. With the push button you can give one pulse at a time. A microcontroller can be programmed to do almost anything. Here are just 3 other examples of what can be done. Now if you look at the oscilloscope you can see some interferences coming from the coil. The laptop is going sometimes crazy near the coil, but the microcontroller seems to be working fine. The final product of this project looked like this. In the video description there is a link to a related blog post where you can find the circuit diagram, the Arduino sketch and design of the prototyping board I'm using. Thank you for watching, I hope you enjoyed the video and maybe you find some new ideas and perhaps want to try out this yourself.